Okay, in this video here, we're going to review some inequality problems, and you're going to do a little bit of a new type of inequality problem, but it's really the same procedure as some of the others. The graph just ends up different in the end. Now, this is a simple inequality. I don't want to say simple as in easy. It's a simple because there's only one symbol. So with the simple, we're looking to get that wall up. You can make those plus negatives because you don't have parentheses. It's the only x you got. Wall dot circle. Since I have a negative multiplier inside of that, I know the sign is going to have to switch after the division. Okay, so that 2, I look up, it's positive, so I subtract it. Now don't go here yet. That's after dividing. The sign does not switch when you are adding or subtracting. So it's going to be negative 18 over there, and over here you got negative 3 times x. Now it's time to then divide by our negative 3. Okay, so we have x on the left, and negative 18 divided by negative 3 is 6. Now, what do we eat? We're eating the x, so we go to the right then, okay? Now, on this line, I don't care if you put the x first or the 6 first, okay? It doesn't really matter, okay? I usually put the x first, but you got to have it eat the x. And that's the answer we're looking for right there, that whole thing. Okay, 25 is less than negative 5x. And again, that's called a simple inequality because there's not simple as in it's easy, but it's there's only one of them. Okay, there's only one symbol. Now, I only have this x here. There's no parentheses. Okay, get your wall up. That side this time, because that's where the x is at. That side of the symbol, that side of the inequality, whatever you want to call it. Okay. So we have a negative multiplier, so that sign then switches. Now, we don't do any adding or subtracting, because on this side, there's nothing outside of that. So the only thing with the x is the multiplier. So I can go straight into my division by negative 5. So we have x on this side, and 25 divided by negative 5 is negative 5. So I have negative 5. It's not eating the x, so it would go this way. Okay. Now, again, I don't care what you put on that line. I usually do the x first and the negative 5, but make sure it eats the negative 5. Okay, you can't change that. That's established. So x can be any number, as long negative 6, negative 7. Think of a number line. That's what it is, a number line. Okay, because these have an infinite number of solutions. That's why the number line has to be used. So negative 2x plus 10 is greater than or equal to 3x plus 35. Okay, so number line. And I can't decide what I'm going to do with the sign because I see 2 x's. Now, you want me to let you know a secret? It doesn't matter which one you get rid of. It doesn't. You can go one on the left, one on the right. I'll do the one on the right. It doesn't really matter. It never did, okay? So I'll pick that one. I'll mark that one. If I look up, that's positive, so I subtract. Now you're wondering, why aren't you writing the sign? Because I don't know, because I have to simplify this so x appears only one time in the inequality. Okay, negative 2 minus 3 is negative 5x, and then you got the 10, and then you have 35 over here. Now I can see what my x multiplier actually is. It's a negative, so that sign the symbol flips. So, I got a 10 outside, minus 10. Don't go down here yet. Do not go down there until after you've divided. So we have 25, negative 5 times x. Now it's time for me to divide. So I have x. 25 divided by negative 5 is negative 5. So my value is negative 5. Now does it eat the x? No, it does not. So it goes this way. So I put x, negative 5. Or you can just make sure it eats the negative 5. Okay, remember to underline it. Okay, now the next one is not a simple inequality. It is known, because I see two symbols, it's called a compound inequality. It's compound. That's me writing compound, C-O-M-P-O-U-N-D. Compound, we use tables, and you can also expect to have two numbers to graph right there. Okay, now, when I see two of those inequalities in the same kind of line, I want to separate them into two simple inequalities. So we have -9 less than or equal to 3x plus 6 over there. Then I make an overlap. On this side, we got 3x plus 6 less than or equal to 18. Okay, now, wall can go up. You can make that plus negative if you want. Okay, that's a positive, so leave the sign alone. The symbol only flips when you multiply or divide by a negative number. We will not be doing either of those because my multiplying number is a 3. 6, you have a positive, so you need to minus him. Line your sign up, line it up. -9 minus 6 is -15. Use a calculator if you're not that good with positives and negatives. It's like a number line. If you're at -9, minusing 6 takes you further out. 3 times x. Now it is time to divide. We would want to divide by our 3. So line your x up, align it where it's at, and -15 divided by 3 is -5. Okay, so my critical number is -5. Circle, fill it. It eats the x, so we will be going this way, just a little ways though. You don't want it to overlap. Okay, wall goes up, dot circle. We have a positive. So that sign will stay the same this time, just like it did here. So we got that 6 we have to deal with. Look up, it's positive. Line it up, and you have 12. You have 3 dot x. Then I would divide both sides by 3. Align the x where it's at. 12 divided by 3 is 4. So I plot 4, circle. You would fill that one. Does it eat the x? No, it does not, so it goes the other way. And you just combine those in. Now, when you have combined, make it just one line, you put x down once. You just put -5 on this side, 4 on this side. Now, make sure here you're eating the 4. Make sure here you're eating the x. So to read that, I would say -5 is less than or equal to x is less than or equal to 4. Okay, now here's your new type of problem you're going to get. It's a compound because you see two symbols, but the graph's going to work out differently, okay? We have a case 1, case 2 when I see that or statement. Case number 1, 3 times x plus 2 has to be less than -7. Or you could have a second case 2 where -4x plus 5 is less than 1. Well, how do you graph this to find all your possible solutions? Well, you're going to make your table. So on one side you got 3x plus 2. You're not going to do the overlap though. They're not going to overlap like they do here. Promise you that. Then -4x plus 5 less than 1. So, you can always make those plus negatives on those. Wall goes up, dot circle. That's a positive, align your sign the same way. Then you go 2 and 2. Now up there we have a positive, so we're going to -2. -7 minus 2 is -9. Then we're going to divide each side then by the 3. Align your x where it belongs, and -9 divided by 3 is -3. So I got this -3. Does it eat the x this time though? No, it doesn't. So that cannot go to the right. Doesn't eat the x, goes to the left. Don't fill it though. Okay, now we do have a negative multiplier, so the sign will be switching here, the symbol. I got that 5 I have to deal with first. I look up, it's positive, so subtract him. So 1 minus 5 is negative 4, and you have negative 4 dot x. Now we can go ahead and execute the division by negative 4. Align your x. Negative 4 divided by negative 4 is 1. So now you have 1. Does it eat the x? Yes, it does. Okay. So we know we're going, ooh, they go apart this time. That means it's like the opposite of what's happening here. Okay. Now it's all the outer parts of it. Okay, now when you have two, when they diverge like that, you can put x down both your lines right there on your graphs, and you're going to put negative 3 and 1. Now you can go negative 3x or x negative 3, but make sure here you're eating the negative 3, and make sure here you're eating the x. Okay, that's write the word or then when they diverge like that. Okay, that's what you're doing, that or stuff, okay? Negative 2x plus 7 less than 1, 4x plus 3 less than or equal to negative 5, okay? So, there's your, it's a compound, so you make your statements. So on one side, you can put negative 2x plus 7 is less than 1. On the other side, you have 4 times x plus 3 less than or equal to negative 5. Okay, dot circle, wall goes up. Ooh, we got a negative, don't we? And you can make it plus negative if you want, but it is a negative, so that sign goes the other way. Now you have this 7 you have to deal with. Look up, it's positive, so you're going to minus it. 1 minus 7 is negative 6, and over here you got negative 2 times x. Now I can go ahead and divide by negative 2. You have x, and then negative 6 divided by negative 2 is positive 3. Circle, don't fill it, and it eats the x, so it goes this way. Okay, next one, you can make that plus negative there. Wall goes up, dot circle. Now the multiplying number's positive, so that symbol stays the same. So you got 3, 3, look up, it's positive, we're going to then minus it. So 4 dot x. Negative 5 minus 3 would be negative 8. And now it's time to divide by 4. So we have x. Negative 8 divided by 4 is negative 2. So now I plot negative 2, circle. We would want to fill that in. Does it eat the x? No, it does not, so it will not go this way. Again, doesn't eat x, goes this way. Use that sheet at all times when you get confused, okay? Now, we got two separate ones, so I put x and x, and then I put 3 and negative 2. Now we need a symbol between them. And if you go negative 2 and x, it doesn't really matter, okay? It doesn't matter the or as long as you have it eat the x on this one and eat the negative 2 on the other one. Don't change the eating part of it. Okay, next problem. X plus 14 is less than 9, or, that should say or, negative 9 times x is less than or equal to negative 45. Okay, so on one side we got x plus 14 less than 9, and on the other side we got negative 9x less than or equal to negative 45. Wall goes up, 1 dot circle. Your sign would stay the same, but you got the 14 to deal with before you worry about the division. Remember, don't flip. You got to have the extra step because you don't flip the sign when you're adding or subtracting. So that's 13. Or no, I'm sorry. 9 minus 14 is negative 5. I apologize. I can't read my own writing. It's 14. Over here you got 1 dot x. So now it's time to divide by 1. So we have x, negative 5 divided by 1 is negative 5. So negative 5 is our critical number, the first critical number we find. And since it eats negative 5, it does not eat the x, it needs to go this way. Now over here, if you want to go plus negative on those, that's fine. Wall goes up, dot circle. I have nothing outside of the negative 9 times x. By the way, the sign is going to symbol flips because 9's a negative. That multiplying number's a negative. So go into your division by negative 9. So we have x, negative 45 divided by negative 9 is 5. Okay. So this time it's 5. Remember, positives over here, negatives over there. Circle, fill it. And this time it does eat the x, so when it eats the x, we'll be going to the right. Okay. So put two separate x's, just put negative 5 and 5. If you like to write the number first, that's fine, but you got to make sure it eats negative 5 here. It's got to eat positive 5, or it's got to eat the x right there. Okay. Now, so you could use this. This is going less than. Okay, but to use this, you got to be putting the variable first. Okay, the next couple. I messed this problem up hardcore. Okay, I want that 7 there, negative. Okay. Okay, so the OR statement. Okay, so on one side we're going to go negative 7x greater than 42. On the other side, negative 5x less than or equal to 10. Okay, you can make those that a plus negative. Wall goes up, dot circle. I see a negative, sign flips. You don't have to add or subtract. You go straight to your dividing by negative 7. X is aligned on the left. 42 divided by negative 7 is negative 6. So you got negative 6, circle. It's not eating the x, so it goes this way. Now this other one, dot circle. Now you got to pay attention here. You would flip the sign again, and I can go straight to division by negative 5. X here. 10 divided by negative 5 is negative 2. Now don't put 2 on that side. That would be positive 2. Negative 2 just goes closer in. Circle. And you would fill that one in, but it does eat the x, so it goes this way. So I put x, x, and I'll put 6, negative 2. Remember, it's when they combine into one where you put just a single x with a number on each side. Here we write it separate. It's got to eat negative 6 here. Here it's got to eat the x with the line. Okay, and then this one here I sort of messed up. You need to flip the sign on that because I wrote it wrong. These two I wrote incorrectly. Okay, both of these, I'm changing them as I go in the video. You don't make that change on your assignment. Don't do that. Okay, table, so on one side, I've got 3x minus 7 less than or equal to 14. The other side, we have negative 4x minus 8 less than 20. Okay, make that a plus negative, and we're ready for the wall, the dot circle. There's a positive, so the sign stays the same. First, you got to deal with the 7. It's negative. We will be adding it. So we got 3 times x. 14 plus 7 is 21. And now it is time to divide by 3. So we have x. 21 divided by 3 is 7. Fill it. It does not eat the x, so it, okay, again, it doesn't, oh yeah, this is gonna wind up interesting. Does not eat the x, okay, so it goes that way. Now over here, wall goes up, dot circle. We have a negative, so that sign is going to go the opposite direction. Then negative 4 dot x. Now it's time to divide. Now I have x, and that's negative 7. So always follow the rules. Don't just try. So this time it does eat the x. So when it does eat the x, it's going that way. And what do you know? They end up, now this one, they end up colliding. okay? When they collide, you write x down once, -7 and 7. Eats 7, eats x, okay? Remember, get that sign to eat the x. It's eating the x here, it has to eat the x here, okay? So when they go apart, you write them as separate, but when they come together, you write it as just one. I think most of these go separate, yeah, I think.